Welcome to Ask and Learn.
Hi, in this question, we are asked to prove by induction this statement, the sum of integer times 2 power by it from 1 to n equal this formula, n minus 1 times 2 to the n plus 1 plus 2. So with this, we will call them the statement p of n when n is positive integers. Now, using induction, we have two steps to prove. So let's go through this basic step. P of 1, that would be one term on the sum on left hand side and put 1 in the formula instead of n on the right hand side. This will be, the first term is 0, so it's 2. Essentially, P1 said that 2 equals to 2, which is obviously true. Then the basic step is clear. Next, for inductive step, we assume that statement true for sum n greater or equal to 1. So p of n is given. We want to show that p of n plus 1, the next statement will also be true. We have to construct this using the information we have from Pn. So let's do this. First, we look at the sum from 1 to n plus 1. You can see that the first n term here is the left-hand side of Pn, right? And since we have Pn assumed already is true for Pn, the formula is true. So we have that the first n term is equal to this formula, right? And so with this, we arrange the right-hand side. We match the first and the third term, pull 2 to the n plus 1 out. The inside will become 2n. And then the number 2 go together with the 2 power in front. So it becomes 2 to the n plus 2. Inside here, we'll left with n. And then plus 2 stay the same. So this is actually the right-hand side of the statement we want, Pn plus 1. So this whole line of equation is actually Pn plus 1. We have shown that using that Pn equals to this term, we have construct the next statement for n plus 1. And so our inductive step is clear as well. And with this two-step clear, we can conclude that we have shown that this statement Pn is true for any n, any positive integer n. And that is how you do it. Thank you.